I told you guys to do the check your progress. Do you guys want these notes or am I good to skip them? It's up to you. You want those? Yeah, if you want a picture, or this video will also be on YouTube either way. It'll be on your Google Classroom. Yep. This video exactly as it happens. Yeah, okay. Is that good for you? Okay. Let's do the check your understandings that we were all supposed to do. 1, you're supposed to list the parent function and then tell what transformations occurred. So those are those answers. This is a quadratic that was stretched vertically by 2, shifted down by 3. This one's an absolute value of x. It's shifted right 4. This one is a cubic that is got a horizontal shrink. I call that a compression. So horizontal compression by a factor of 4 and a reflection over the x-axis, which changes the sign of all the y's. Right, those would be the, in words, what happened in 1. Any questions on any part of 1 that you guys might have missed? Or there's a lot of writing you didn't do? Two, give the equation of the parent function y equals the radical or radical x after it has been shifted left 7 and up 2. So left 7, that affects the x's. X's goes on the inside. It does the opposite of what it looks like it should do. So left 7 is adding 7 on the inside, and then up 2 is plus 2 on the outside. Any questions on 2? I think both those are pretty easy. 3, I think, might have been the most difficult one of them, maybe. We got a transformation of a parent function. Which function describes the graph correctly? So I would start by looking, where are my shifts left, right, up, or down? So this graph needs to go, think about the vertex. It needs to go right 3, down 4. So which one of these shifts right 3 and down 4? Well, they're all down 4. These two are plus 3, so that's going to go left 3. The minus 3s go right. So that's got me narrowed down to C or D, right, just from shifts. Now the harder one is, has there been a vertical compression? That's what's happening here. Or has there been a horizontal stretch? So if you look at the graph, do you guys know how you could tell just by looking? It's okay if you don't, because we haven't really talked about this. For a parent function, x to the second, if you think about those critical points, specifically -1, 1, 0, 0, 1, 1, right? These 3, normally at the vertex, to find the next critical point, we could go right 1 and up 1, and left 1 and up 1 for its parent function. You see how that goes from 0, 0 to 1, 1 to -1, 1? So what's happened here to this graph from its original parent function? It's went this direction. So it has to either be a horizontal stretch or a vertical compression. This one is the vertical compression. This one was a horizontal stretch. So that didn't help. So my last class didn't catch that. And I just said it was a horizontal compression, I guess, and went back. Anyways, because I'm doing it right for you guys. I did it wrong for them. So here's another way. Let's plug in these values. That'll be my next answer. So if I plugged in 4, no, here's a crosshair. If I plug in 5, I need to get out a value of -2. You guys follow that? Because right 5, down 2 is that point. So let's just try. I don't know what's going on. So if I go here, this is going to be 1/2 times 5 minus 3 squared minus 4. That's going to be 2 squared. I know you put it in your calculator. I don't have a calculator, unfortunately. That's a half minus 4. This one does give negative 2. Okay, if I plugged in here a value of 5, 1/2 times 5 minus 3 squared minus 4, this would be 2.5 minus 3 is a half. A half times 2 is positive 0.25. Did I do that right? 5 times a half is 2.5 minus 3 is negative a half squared is 0.25 minus 4. So this gives negative 3.75, should be the y. So it has to be C. If it was the other, it would be 5 negative 3.75. It would be here. Right, so it's still getting wider, but it's getting much wider than C. I'm glad I waited to record until I got with you guys because I screwed it up last time. I just said this was a horizontal compression. Not compression. Okay. 4. Pilar's parents give him an allowance amount, A of T, based on his age, T, which of the following would give the allowance of Pilar's younger sister, who is 3 years younger than he is. It is C. What does A give? Like, if you had to put this in words, what is this? This is the amount Pilar makes minus $3. You following? It's the Y value, the amount he makes, but he lost $3 from that. So what would B be? The amount of money Pilar makes, $3 more than that. What would D say? Now then, the plus 3 is on the inside, on the X. It's affecting the age. So this would be the amount of money that someone 3 years older than Pilar would make. And this is the amount of money someone 3 years younger than Pilar would make. Let's go with that. Can you put that in words from symbol? Now, most phone plans have unlimited talk and text, but offer different amounts of data at various costs. I know what you're thinking. I'd have just sent Snapchats. That didn't exist. Sorry. That's that. You had to text, or you had to call them. Or you could have got on MSN Messenger, but that's a whole different. Let's don't even go down that. Today, we'll look at some pricing structures for phone plans. So what factors play a role in choosing a cell phone service provider and picking a plan? So if you were having to buy your own cell phone plan, what things would you be looking at? So the cost. What else?
How many minutes is it?
Not, I mean, I guess.
Just say no.
Well, I mean, aren't most things now unlimited talk and text? I mean, I'm with you. Back when I was in 8th grade, that'd be a great thing to look at was the minutes. But I don't even know if they do minute. They probably still do minute plans, but
What time period are we at right now?
right now,
Okay.
or now, today. If you're buying a phone today, you think they had 4G back then? We're looking at 4G phone plans.
The amount of service.
Thank you. Where you live, do you have one service provider that works better than the other? Deal. Used to, there were only a certain companies that would have different phone options. Again, everybody wants an iPhone now, and you can get that with anything. So, they say access to Wi-Fi and need for data And are there any deals or family plans? I think we encompass that with cost. I think that's both of them. Okay, 2, Metro by T-Mobile offers an unlimited text and talk options with 2 gigs of data per month for $30. If you exceed 2 gigs, you pay a rate of $10 per gig for each additional gig. So what would be the monthly phone bill for a person that used 1.7 gigs of data? $30. Is everybody good with that? B, what would be the monthly bill for a person that used 3.5 gigs of data? That's what mine says. Mine agrees with you. I disagree, but
You don't think it's 45?
I don't.
What do you think?
I think it's 50.
Well, you're using a half.
Can you buy half a gig?
Depends on the plan.
I guess you're right. So according to them, that's what they said. They said it's 30 plus 1.5 times 10, which is $45. But back in my day, when you bought them, if you went over your gigabyte allotment, you had to buy the next. So like, if I was purchasing in 4 gig allotments, if I went over 4 gigs, I had to buy 4 more gigs. I couldn't just use, if I just was 2 days to the end of the month, I couldn't just use half a gig and get a prorated price. You guys know what prorated means? That's what you just did. By paying for 1.5, that's prorated. You're only using what you paid for. That comes up a lot with, like if you wanted to go to Dollywood today and you didn't have an annual pass. At Dollywood, their passes only go for the calendar year. So if you went to buy a pass, you would pay the same price I paid for mine in January. It's not prorated. If they said because there's only 4 months left in the year, we're only going to make you pay 4/12 or 1/3 of the original price. That's called prorated. But it's not prorated. So I think it shouldn't be prorated. This is a prorated metric. Anyways, I can tell you I don't purchase stuff yet. That's okay. I wouldn't know what that meant either when I was your age. But now I'm an old man shaking my fist at the world. So how much would I pay if I use 0 gigs? That's incorrect. I'm on the plan. I just didn't use any gigs. See, this is what I mean by prorated. I pay $30 to be on the plan. So if I use no gigs, it's $30 still. What if I used 1 gig? How much did I pay? $30. What if I used half a gig? So it's 30. It's constant, right? It's going to be a horizontal line all the way up to the value of 2. And then what happens once I get to 2? What if I use 3 gigs? I would pay 40. If I use 4 gigs, I would pay and 5, 60, and 6, 70, and all those values in between, because it's apparently prorated. Or if I use 2.5 gigs, I would pay 35. Any questions about this? Write a... Okay. So let's think through this. What kind of rule could we come up with?
You need a 30.
I do need a 30.
And an
So when do I pay $30?
What, 0 through 2?
What 0 through 2?
When X is,
When X is between 0 and 2. I pay $30. So the rule is 30 if x is between 0 and 2. Is it 30 if it equals, like if x equals 0, is it still 30?
Yes.
So I need an equal to sign. If x is equal to 2, is it still $30?
Yes.
So I need an equal to sign there too. So this says when, the way I read these compound inequalities, I always read it from the x because it makes more sense to me. I say if x is greater than or equal to 0 and less than or equal to 2. Instead of reading 0 is less than or equal to x, less than or equal to 2. That just doesn't make any sense to me in my head. So I always go from the x. Okay? So that's good. What else could it be though? What if x is not between 0 and 2? So how do I do plus 10 with an x in there though? Yep. And what's my condition here? If
X is less or greater.
x is greater than 2. I'm not finished. This doesn't work. I hate to tell you guys. If x was 3, how much did I pay? 40. Your rule says I paid 60. So when it's 3, what do I want to multiply 10 by? 1. But I'm multiplying by 3. I'm too many. 2. That just reminds me of my best friend wearing when we had Miss Cooper as a teacher, and she was making she had a tutu for Caroline when she'd been before Caroline was in school, and Miss Cooper left the room, and Trey grabbed that tutu and had it on when she come walking in there. Anyways, that's a whole different. This is the piecewise function. That's funnier for some that know Trey. You don't know Trey, it's still kind of funny, but you know, whatever. Especially now that you know the rivalry between Clay and Trey, that's even better. The rivalry bromance, I don't really know what to classify it as. It's product or the GDP changes with respect to time. So 1, what do you notice about the graph and what do you wonder? That's just your opinion right now. What do you notice about the graph? It's not constant. What is it? How would you explain what it looks like? It looks like waves, right? We're up and down in waves. So GDP increases and decreases, but when it increases, does it increase to the same height every time? No, what's happening between B and D? It's getting a little bit higher. And then when you look at its valleys, its low points, what's happening to the low points? They generally are getting higher too. Right? So in general, the GDP is growing, but it does have ebbs and flows. It does have its ups and down moment. So they say the GDP increases and decreases in waves, but there's a general upward trend. And then they said they wondered, what are the units on the x-axis? Right? That's just something you could wonder. It says time, but what kind of time? And again, that could just be anything. 2, at each point, A, B, and C, determine if the GDP is increasing or decreasing. So at A, what's happening to the GDP? At A. How do you know? Yeah, think about slope of a tangent line, right? So A is increasing. What about at B? B, it is decreasing. We're heading down at B. And what about C? C is also decreasing. Three, the max and min values of a business cycle are called the peaks and the troughs. Label them on the graph. So they just want you to go and pick a peak and a trough. A peak and a trough. So right here at the very top, in blue, this would be considered a peak value. Down here would be a trough. Hope I spelled it. T-R, yep. Here is another peak. So I'm just going to put peaks. Here is another trough. What can you say about the GDP at these peaks and troughs? The rate of change. So what are they asking for? The slope of a tangent line at a peak and a trough. Heading up to this peak, what is the rate of change, positive or negative? After that peak, it is, what is it at the peak? Slope is 0, right? It's a horizontal line. What about at a trough? It was decreasing. After it, it is increasing. At that trough, the rate of change is 0. Another horizontal line. Horizontal line, horizontal line. Everybody follow that? I know that's kind of a new concept we're looking at. Slopes of tangent lines. Here's what they say. The rate of change is 0. And the slope at all max and min values is 0. Rate of change is 0. Is the GDP increasing and decreasing at constant rates? No. Explain.
Can't do both. You can't increase and decrease at the same time.
Okay. My question is, when it's increasing here and when it's decreasing here, are those at constant rates? Is the rate of increase always the same? Is the rate of decrease always the same? How do you know?
As it reaches the peaks, it becomes constant.
Okay.
So the slope of the tangent lines changes.
It does. It changes in which direction? It's getting less positive, closer we get. So the slopes of tangent lines are changing. That's one way we could explain it. How else could we explain it? What would have to happen if it was increasing at a constant rate?
Linear.
It has to be linear. Between here and here, is that linear?
No.
Between here, are those linear?
No.
It's not linear. That's another way you could explain it. Alright? Slopes of tangent lines is like the next level of explaining it. That's the calculus way to explain it.
Yeah.
That's good. I like it. Everything you said was correct. But at this level, all you have to know is it's not a constant rate of change because it's not linear. But you're not wrong. I think they would accept that answer. 5, at point D, GDP is increasing. Is the growth of GDP speeding up or slowing down? And how do you know? Yes. The graph is getting flatter, is the way they explain it. But it is, as we get closer to the peak, growth slows. So at D, is the graph concave up or concave down? Down. At D, the graph is concave down. Looks like an umbrella. 6. When is GDP changing the fastest?
B, C, and F, D.
Okay. Okay. I think you're on the right tracks. I told you I was going to have the graph. I knew I would. Dang, Jurassic Park's going to make me not finish. If you think here, slopes of tangent lines, we're here, here we are, here we are, here we are. So where is the GDP changing the fastest? So right here I'm looking for, where's the slope the most negative? Right? Where's that at? It's between B and C. What about here? Where's the slope the most positive of a tangent line? It's right between F and D. It ends up, it's right here. And notice what's happening at these points. Think about concavity. This is concave down until here. And then it's concave up. You see, the point where it's increasing or decreasing the fastest is the point concavity changes. It's along that dotted line. I know we're about out of time. Try to finish the rest of these up. I really think you can. The whole discussion there's about concavity, and they want you to realize rates of change are changing, and where it's the greatest, that's where the concavity changes. But I'll do the answers tomorrow, but try to check your progress and the rest of that. And now, if you want to, also 2.1 and 2.2, I think I'm teaching everything that you need to cover that. So if you have any questions on 2.1 or 2.2, you can ask those when coming first in class. Okay.
So did you already grade 2.1?
It grades it